So we're going to have this stack diagram side by side with the code again. So you should be able to see here the most important parts of the code. I'm going to scroll down so that my function is visible. And let's go ahead. Let's see exactly what's happening. So you already have in a previous video, the detail of what was happening when we had actually my function returns the address of a local variable. Now let's see what happened with this version, which is using a malloc to allocate new memory, and then returns the address of this newly allocated area of memory. So let's start with the activation record of the main. I have a variable named ptr inside the main, local variable ptr. This local variable ptr initially is set to null. Okay, so let's go with that. As I am calling, and I'm going to scroll back up, okay, I have a local variable result too, which I was forgetting, so that's a good thing that I scroll back up. Result is initialized to 0.0. Okay, as I am calling my function, a new activation record is pushed on the stack. My function has one local variable, tmp_ptr, okay, no parameters. tmp_ptr is assigned whatever malloc returns to us. So when I call malloc with size of int, malloc is going to find for me a memory space large enough to accommodate one integer. So let's say 4 bytes on my 32-bit system. Okay, this is going to be allocated in the data segment. The address, let's call it alpha, is going to be assigned to tmp_ptr. Therefore, tmp_ptr now points to this memory space large enough to accommodate one int value. Of course, you know how malloc works. This memory space is not on the stack. Okay, it's in another segment of my program memory space. So when I am done with this function, okay, I verify that tmp_ptr contains an address. Then I assign here 42 inside this memory location, alright, by dereferencing tmp_ptr. And when I'm done, I return the value inside tmp_ptr, which is alpha. And this activation record, for all intent, is no longer usable. So tmp is pretty much gone. I return the address alpha to the main, and this address is actually stored inside ptr. So ptr now is pointing to this integer. And when you do the correct stack diagram, of course, if you try to do stack diagrams to debug a program or understand what it does, but you misunderstood, how to what's happening, how to draw what's happening, etc., your stack diagram is going to have nothing to do with reality, and it's not going to help you much, trying to find bugs and understanding what the program actually does. But assuming that you understand how to draw this stack diagram, they are like an invaluable tool to help you actually debug. Here, you can see that, well, when you dereference ptr here to display the value, you're going to display 42, which is here. Then when you call sum, unlike with our previous version of the code, when you call sum, you are going to overwrite what was in the activation record right after the activation record of the main. Okay, so here 2 parameter 1, 2. Okay, I pass some value 42.0, 99.0. I make the sum of the two. I return the result from my function. So this activation record here is gone. But as you can see, all this work that we've done on the stack, okay, creating new activation record, popping it out of the stack when we don't need it anymore, okay, all of this didn't affect at all the data segment of our program, where this newly allocated integer containing the value 42 lives. So when I'm back in the main and I do again dereference ptr, I'm accessing this area of memory, and therefore I'm displaying the value 42 again. And then all I have left to do is to free ptr. So what this is going to do, it's going to pretty much mark this area here as no longer usable. But the 42 is still there. Okay, so at memory address alpha, I have 4 bytes which encode the value 42. Of course, those 4 bytes are no longer, reserved for my usage. So the next time I do a malloc, let's say I do a malloc for 8 bytes, I may receive this chunk as result, okay, memory address beta, and I'm going to overwrite here and overwrite the old value, pretty much kind of like what happened with our activation record, but with dynamically allocated memory located on the data segment instead of memory located in an activation record part of the program activation stack, okay? But the idea is this memory here has been freed. It's no longer available to me. I should not use it anymore, even though there is still the bits of value here hanging around in memory until they are overwritten. So that's another source of common bugs with pointers.